session. Our next section is use tools to optimize Power BI performance. So, optimization is critical when working with the solutions that need to scale. And this is what we are going to learn in this section. So, optimize Power BI solutions. You can optimize your solution at different architectural layer. So layers include data sources, data model, visualization, including the dashboards, Power BI reports, and Power BI paginated reports, and the environment, including capacities, data gateways, and the network. So the data model support the entire visualization experience, and these data models are either external hosted or internal hosted, and in Power BI they are referred to as data sets. So it is important to understand your options and to choose the appropriate dataset type for your solution, whether it's import or direct query or composite. So you can optimize the Power BI environment by configuring capacity settings, sizing data gateways, and reducing network latency. Now, another optimizing Power BI solutions are, first one is aggregation. So, aggregation in Power BI can improve query performance over very large direct query data sets. And by using aggregations, you can cache data at the aggregated level in memory. Aggregations in Power BI can be manually configured in the data model as described in here. Okay, or for premium subscription automatically by enabling the automatic aggregation feature in dataset settings. Then we have dual storage mode. So in Power BI desktop, you can specify the storage mode of a table. The storage mode lets you control whether Power BI desktop caches table data in memory for reports. So setting the storage mode provides many advantages, and you can set the storage mode for each table individually in your model. Now, what are the benefits of it? First of all, the query performance. So, as user interact with visuals in Power BI reports, data analysis expressions, queries are submitted to the dataset. Caching data into memory by properly setting the storage mode can boost the query performance and interactivity of your reports. Also, next benefit is large data set. So tables that are not cached don't consume memory for caching purposes, and you can enable the interactive analysis over large data set that are too large or expensive to completely cache into memory. So you can choose which tables are worth caching and which aren't. Another benefit is data refresh optimization. So you don't need to refresh tables that are not cached. You can reduce refresh times by caching only the data that's necessary to meet your service level agreements and your business requirements. Another benefit of it is near real time requirement. So, tables with near real time requirements might benefit from not being cached to reduce the data latency. Another benefit of dual storage mode is write back. So writeback enable business user to explore what if scenarios by changing the cell values. A custom application can apply changes to the data source, and tables that are not cached can display changes immediately, which allows instant analysis of the effects. So, set the storage mode property to one of the three values. Either you can set it to import mode, as it is shown in the figure as well, or direct query, okay, or you can set it into the dual mode. So whenever you are setting into the import mode, so imported table with this setting are cached, and queries submitted to the Power BI data sets that return data from import tables can be fulfilled only from cached data. If you are setting it to the direct query, so table with this setting are not cached, and queries that you submit to Power BI dataset, for example, DAX queries, and that return data from direct query tables can be fulfilled only by executing on demand queries to the data source. So queries that you submit to the data source use the query language for that data source, for example, SQL. And if you are setting it to dual, so table with this setting can act as either cached or not cached, depending on the context of the query that's submitted to the Power BI dataset. So in some cases, you fulfill queries from cache data. In other cases, you fulfill queries by executing an on-demand query to the data source. So changing the storage mode of a table to import is an irreversible operation. Once set this property can't later be changed to either direct query or dual. So we have to be very careful, okay, while selecting the storage mode. Another solution is hybrid table. So a hybrid table can help to strike the right balance between query performance and data freshness. And a hybrid table is essentially a large table that has one or multiple import mode partitions, okay, as well as another partitions in the direct query mode. So if the direct query partition is sufficiently small in comparison to the import partition, the query or the response round trip between the Power BI and the data source should still be reasonably fast, while access to the bulk of the data is already super fast in import model. So import and direct query data is presented to user as single query table with business definition and calculations. All right. So this was about optimizing the Power BI solutions. Now let's move on. Now optimizing the Power BI models using tools. So you have built Power BI reports and they are running slow. How do you identify the source of the problem? The report could be slow because of the issue at the source, the structure of the data model, the visuals on the report page, or the environment. So, optimizing the performance in the context of this section means making changes to the data model so that it runs more efficiently. And the tools we are discussing in this section will help you to troubleshoot and improve the data model, which ultimately improves user experience. Ideally, You should assess performance as you move through the stages of the development life cycle, development testing, production, and optimization of your solution. Okay, so let's discuss all of these Power BI model, all of these tools in our upcoming slides. So using the performance analyzer. So performance analyzer help you to optimize at two of the four architecture levels. Okay, the data model and report visuals. The performance analyzer is a great place to start when you are optimizing reports. And it displays and record logs that measure how each of your report element perform when user interact with them. You can also see which aspect of their performance are most or least resource intensive. You can immediately see results, make changes, run the analyzer again, and see the impact of the changes you have made. So after you start recording, take actions in the report. For example, move one report tab to the next, select a slicer item, or interact with any of your visuals. So, any actions you take in the report are displayed and logged in real time in Performance Analyzer pane in the order that the visual is loaded by the Power BI. Okay. Then the performance analyzer is looking at the time it takes for each visual to query the data model and render results. And this is the time from when a user does something on the page to when the visual is rendered in milliseconds. In the example on the slide, three actions were taken after recording started. First is navigated to a new report page. Second is change a slicer value. And third is cross highlighted a table. So as user interact with visuals in Power BI report, DAX queries are submitted to the dataset and cached into the memory. Because of this, you may need to clear the DAX query cache to get accurate result in Performance Analyzer. You can clear the cache by either closing and reopening your reports or using DAX Studio. Okay, so this was about Performance Analyzer. Now let's move on to our next slide. Now using the DAX Studio. So DAX Studio is an open source tool for executing DAX queries against Power BI and analysis service models. It is useful for various purposes, like it is used DAX Studio is useful for reviewing the contents of your data model, for writing and optimizing complex DAX formulas and queries. Okay, so before jumping into the optimization, it is important to understand what is happening under the hood of Power BI. So, by using compression algorithms and multi threaded query processors, the analysis services VertiPaq engine delivers fast access to tabular model objects and data by Power BI. Power BI read the content of your data source and transform it in the internal VertiPaq columnar data structure where each column is encoded and compressed. So dictionaries and indexes are created for each column And finally, the data structures are created for relationship and computation and compression of calculated columns occurs. Okay, so DEX queries are being processed by two engines, the formula engine and the storage engine. Okay, and we will talk more about these engines. So calculation using DAX, either measures or columns are a part of DAX query, which is processed by two engines in VertiPaq. Okay, and when a query is processed, the formula engine process the request, ask the storage engine for data, and perform necessary calculations. Then this storage engine, it retrieves and aggregate data request by the formula engine. So in this diagram, which is shown on the screen, the DEX query is sent to the tabular model in step 1 and 2. The request is then processed by formula engine and sent to the storage engine, which is represented by step 3. Okay, and in step 4, the storage engine either retrieve the data from model and store it in memory for import mode, or passes the query uh, onto the data source for direct query. So for import mode, refreshing the data will retrieve the data from the source. So isn't it interesting? Now let's move on to our next slide. So view model metrics using VertiPaq Analyzer. So viewing the VertiPaq Analyzer metrics in DAX Studio is a great way to get an overall view of what's going on in your data model. VertiPaq Analyzer and reports the memory consumption of the data model and can be used to quickly identify where you are spending the most memory. In short, you can use VertiPaq Analyzer to make memory gobbling offenders obvious, rectify them in Power BI, and then rerun the VertiPaq Analyzer to see the immediate benefits of your data model updates. The VertiPaq engine only store the data in memory in import model, and if you are using direct query, the VertiPaq engine simply send that query to the source. This means that viewing the VertiPaq Analyzer metrics will only be helpful for import or composite models. So you can look at the size of the table, column, etc. in bytes. The displayed size in bytes are evaluated prior to the compression. So if we notice the model in the image, it contains a table that consume 99.6% of the database memory. And by drilling into the table, we can see that two columns, end start date and end date and start date, okay, are gobbling up the most memory. And when we take a look at those two columns back in the Power BI desktop, we can notice that they are date and time columns. Okay, so date time column inherently have high cardinality due to all the possible combination of dates and time. Okay, so this was about the DAX Studio. Now let's move on to our next slide. So optimize data model by using best practice analyzer. So Tabular Editor uh, is an alternative tool for authoring tabular model for analysis service and Power BI. And the Tabular Editor 2 is an open source project that can edit a BIM file without accessing any data in the model. So Tabular Editor, it enable user to easily manipulate tabular models and can be used in different ways. So Tabular Editor can be used to quickly edit data models, automate repetitive tasks using scripting, incorporating DevOps with tabular models, and running BPA rules. So, BPA rule basically are a set of rules run in the tabular editor and that notify you of potential modeling misstep or changes that you can make to improve your model design and performance. It includes recommendations for naming, user experience, and common optimization that you can apply to improve performance. Okay. So to use the predefined BPA rule, we can download the BPA rule.json file from GitHub repository, and the rules are divided into categories for easier viewing. For example, performance, index expression, error prevention, formatting, maintenance. Okay, so BPA was designed to enable you to create custom rules and best practices for your organization. If the best practice rules don't suit your needs, you can create rules required for data modeling best practices as you deem appropriate. All right, so this was about the third topic that we have learned. All right, now let's move on to the next one. So, our next topic is enforce semantic model security. So, let's get started. Restrict access to Power BI data model. Okay, so you can enforce model security by restricting access to subset of data and by restricting access to specific model tables and columns. You might restrict access because some report consumers are not permitted to view the specific data, like sales result of other sales regions. Achieving this requirement commonly involves setting up row level security, which involves defining roles and rules in that filter data model. You can also set up object level security OLS to restrict access to entire table or column. So we can restrict the access to Power BI model data by various techniques. Like first one is apply star schema design principle. So we recommend you to apply star schema design principle to produce a model comprising dimension and fact tables. And it is common to set up Power BI to enforce rules that filter dimension tables, allowing model relationship to efficiently propagate those filters to fact tables. Then another way is defining the rules. So rule expressions are evaluated within the row context. And row context means the expression is evaluated for each row using the column values of that row. So when the expression return true, the user can see the row, and you can define these rules that are either static or dynamic. So if we talk about the static rules, so the simplest static rule that you can create restrict access to all the table rows. You can also restrict access to a particular region. Okay. And when we talk about dynamic rule, so dynamic rule use specific DAX functions that return environmental values. So environmental values are returned from three specific DAX function, which are username or user principal name. So which return the Power BI authenticated user as a text value, and it could also be specified by custom data function, basically which return the property passed in the connection string. Okay, and non-Power BI reporting tools that connect to the dataset by using a connection string can set this property. Like Microsoft Excel also can set the custom data property. Okay, now another way to restrict the access to Power BI data model is validate roles. So when you create roles, it's important to test them so that we are ensured that they apply the correct filter. And for data models created in Power BI desktop, there's the view as function that allow you to see the report when different roles are enforced and different username values are passed. We can set up the mapping also as a way to restrict access. Okay, so a role mapping basically must be set up in advance of users accessing Power BI account. And role mapping, it involve um, assigning Azure Active Directories, security objects to roles, and security objects can be user accounts or security groups. So for Power BI desktop developed models, role mapping is typically done in the Power BI service. For Azure Analysis Service or SQL Server Analysis Service models, mapping is typically done in SSMS. Okay. Now, fourth way to restrict access is using SSO for direct query. Okay. So this is the fifth one actually, using the SSO, which is single sign on for direct query. So when your data model has direct query table and their data source support single sign in, single sign on, so the data source can enforce data permissions, and this way the database enforce RLS, row level security, and Power BI dataset and reports on the data source security. Okay, so these were the few ways of restricting access to Power BI model data. Now let's see what we have in our next slide. Restrict access to Power BI model objects. So object level security can restrict access to specific tables and columns and their metadata. And typically, we can apply OLS to secure objects that store sensitive data like employee personal data. So, when Power BI enforces object level security, not only it restrict the access to the tables and columns, but it can also secure metadata. And when you secure the metadata, it's not possible to retrieve information about secured tables and columns by using dynamic management views. Okay. So OLS is a feature inherited from Azure Analysis Service AAS and SQL Server Analysis Service SSAS. The feature is available in Power BI Premium to provide backward compatibility for models migrated to the Power BI. For this reason, it is not possible to completely set up OLS in Power BI Desktop. So let's first discuss how can we set up object level security. So to set up object level security, you can start by creating the roles. You can create roles in Power BI Desktop in the same way we do when we set up RLS. Next, we need to add OLS rule to the roles. Okay, and this capability is not supported by Power BI Desktop, so you will need to take a different approach. Then you add OLS rule to Power BI Desktop model by using XML or for analysis, which is XMLA endpoint. And XMLA endpoints are available with Power BI Premium, and they provide access to analysis services engine in the Power BI service. Now, what all considerations are there while creating object level security? So, consider carefully whether OLS is the right solution for your project. When a user opens the Power BI report that queries a restricted object, the error message could be confusing. All right, and it will result in a negative experience. So, to them, it looks like the report is broken, and the better approach might be to create a separate set of modules or reports for the different report consumer requirement. Okay. Now there are some restrictions also. The first one is you cannot mix RLS and OLS in the same role. If you need to apply RLS and OLS in the same model, create separate roles dedicated to each type. Also, you cannot set table level security if it breaks a relationship chain. For example, if there are relationships between table A and B and B and C, so you can't secure table B. If table B is secured, a query on table A can't transit the relationship between table A and B and B and C. So in this case, you could set up a separate relationship between table A and C. Okay, so this is how we can restrict access to Power BI model objects. And now let's move on to our next slide. Okay, so apply good modeling practices. So it is critical that your model enforces data permissions correctly and efficiently. And the following list provide you with good development practices to apply. So first one is strive to define fewer data models with well designed roles, and you can also strive to create fewer roles by using dynamic rules. Okay, a data driven solution is easier to maintain because you don't need to add new roles. And whenever possible, create rules that filter dimension table instead of fact table, so it will help to deliver faster query performance. You can also validate the model design including its relationship and relationship properties, and are correctly set up. Okay, then you can also use a principal user principal name function instead of user name function. So it provide consistency when validating the roles in the Power BI desktop and the Power BI service. So rigorously validate RLS and OLS by testing all the roles, and ensure that the Power BI desktop data source connection uses the same credentials that will applied when set up in the Power BI services. So these were the few practices for applying good modeling. Okay, as how can we model? Okay. So now, with that, we have come to an end of today's session, and let's recap what all things we have learned. So, in today's session, we learned different terms and technologies and different features. Like, first, we learned about scalability and working with large data, uh, which is achievable in Power BI. So, the correct model framework, a proper data model, and using fabric features like large scale data storage, which enable performant enterprise reporting in Power BI. Then we also learned about creating model relationship, and the most common there we learned that the most common model relationship is one to many relationship. Okay, and once we gained the mastery of model relationship and how to set them up when we are on the way to develop more complex and efficient model. Okay, and then we also learned about creating Power BI model relationship. So there we reviewed DAX concepts. We created calculation groups. We also learned about enforce Power BI model security and using tools to optimize Power BI performance. Then we learned about enforce semantic model security, and there we learned different techniques like restricting access to Power BI model data with RLS, restricted access